Welcome back, Wolfpack. This is part 2 of lesson 4.4, triangle proofs. If you are one of my even day classes, you are doing this without me, with the guest teacher, and I'm expecting you to be on your best behavior while you are doing this. I do understand that proofs are not something that are super easy to comprehend. So if you have questions while we're doing this, I really suggest that you write them down in your margins or maybe make a note next to the parts that you don't understand why we chose those. So we're going to move right into example 3. So we're going to write proofs. Well, I think you guys know that by now that normally the first couple of statements are what is given. So they gave to us that quadrilateral, and I'm just going to abbreviate, right, the word quadrilateral JKLM is congruent to quadrilateral NPQR. That should be the word given. So the quadrilaterals as a whole are equal to each other. They also told me that angle J is congruent to angle K. So this angle is congruent to that angle. And that would also be a given. Lastly, they want me to prove that angle J is congruent to angle P. So I put the prove down on line 4. So what I'm looking at is I know that angle J is congruent to angle K, and I have to find some way to prove that angle J is congruent to angle P. So since J, K, and P are the angles I'm going to deal with, I'm going to see, wait a minute, is there a way that I can prove that angle K is congruent to angle P? And there is, because if you notice, and K is the second letter, and P is the second letter, which means since the two quadrilaterals are congruent, their individual pieces are congruent as well because of the theorem we learned earlier that corresponding parts of congruent triangles are congruent. And even though this is not a triangle, it rings true for all shapes, that corresponding parts of congruent shapes are congruent. So I now know that angle K is congruent to angle P because they are the corresponding angles of both of their quadrilaterals. So then if you notice, I had angle J is congruent to angle K, and angle P is congruent to angle K. So I can just cut out the middleman and say now, well, that means angle J is also congruent to angle P because of the transitive property. So if I know that two shapes are congruent, that means the individual pieces of their shapes are also congruent as well. Complete the proof. This one's nice and easy. It says that triangle ABD is congruent to triangle ACD. Obviously, the first reason is the given. They tell us those two shapes are congruent to each other. They're wanting me to prove that D is the midpoint of BC. Well, if D is the midpoint of BC, that means that BD is congruent to CD. Well, is BD congruent to CD? Yes. We already know that BD is congruent to CD because they are the corresponding parts of the triangle. So because I know that the two triangles are congruent, their corresponding parts of congruent triangles are also congruent. So since BD is congruent to CD, that means D has to be the midpoint, because that's what the definition of midpoint is. Midpoint means it's cutting something in half. So again, I knew that the two triangles are congruent, which means I was able to say that BD was equal to CD because they're their corresponding parts. And so since they're equal to each other, D is the midpoint that is dividing them in half. Example 5, we were given that L is parallel to M. So L is parallel to M. You should be comfortable with putting the word given in there. We were also given that angle 1 plus angle 4 is equal to 180 degrees. That's also the given. I'm sorry, angle 1 plus angle 4 plus angle 5 is 180 degrees. Lastly, we're trying to prove that angle 1 plus angle 2 plus angle 3 is also equal to 180 degrees. So I want to keep angle 1 but I need to replace 4 and 5 with 2 and 3. Okay, so I need to try to figure out how I can replace 4 and 5 with 2 and 3. Well, if you look, I know that these two lines are parallel. They told us L and M are parallel. And if I have my transversal, I know 4 is equal to 2. Angle 4 is congruent to angle 2 because they are alternate interior angles. I also know with this transversal that angle 5 is congruent to angle 3 because they are also alternate interior angles. So now I had 1, 4, 5, but now I know 4 is equal to 2 and 5 is equal to 3. So I can replace, or I can substitute 2 in for 4 and 3 in for 5. So I can say angle 1 plus angle 2 plus angle 3 also equals 180 because of the substitution property. Substitution. Almost got it right. I know trying to think through where to even go is difficult. I get that 100%. But hopefully as you're seeing me work it out, you at least see why I'm able to substitute things in and why things are congruent. That's my goal for you. Now, example 6 is a little different. We've never had something, we've never had a problem like this where the givens were not first, okay? So, sometimes if you're drawing a shape, let's say I have a triangle and I needed to do something with it, I can draw the midpoint and say, this is the midpoint. I'm basically measuring it out and saying, that's the middle, that's the midpoint. Because every line has exactly one middle. And that's what they did here. They're wanting us to prove something. And so before I even started with the proof, I decided, you know what? They didn't give me the midpoint, but I'm going to do it. So if you notice, steps 1 and 2 are things that we got to do on our own. It says, let D be the midpoint of BC. So D right here, I made that the midpoint of BC. And the reason I'm allowed to do that is because every segment has one midpoint. So then I drew an auxiliary segment, AD. I drew a line from A to D because 2 points make a line. So then I was able to say that BD is equal to CD, just like one of our previous proofs, because of the definition of midpoint. So now I know that BD is equal to CD. I also know that AB is equal to AC because they gave us that. So now we're kind of back at the givens. And I know that AD is equal to AD, equal to itself. Oops, sorry about that. I want to use green. Because of the reflexive property. So what I have here are 2 triangles. And if you notice, they're equal to each other. Triangle ABD is congruent to triangle ACD. And that is because of side, side, side. They have 3 sides equal to 3 sides. So those 2 triangles are equal to each other. And I needed to prove them equal to each other because I'm trying to prove that an angle from each of them is congruent. Well, since I know the 2 triangles are congruent to each other, their corresponding parts are congruent. Notice letter B is the middle letter, letter C is the middle letter. So those are the corresponding angles. So corresponding parts of congruent triangles are congruent. Basically, if you know that 2 shapes are congruent, then you can say that one piece of one shape is equal to one piece of another. Think about it if I bought 2 of the exact same cars, okay? 2 brand new, whatever. I don't care, BMWs. If they're exact same model, exact same year, exact same everything, the steering wheel of one is exactly equal to the steering wheel of another. And that's what we have here. If we have 2 triangles or 2 shapes that are equal to each other, one piece from one is exactly equal to one piece of another. So, and that's corresponding parts of congruent triangles are congruent. CPCTC. Again, I'm not expecting you to really understand exactly where we're going with this, but hopefully you're getting better and better at proofs as we're going along. If you have any questions, please make sure you're writing them down. And I'm asking you to be in your best behavior for the guest teacher. And I will see you next class. Have a great day, Wolfpack.